So, this was then an atrocity with 17 parts. Uh, yeah, botch diode, yeah, rectifying diode, but nevertheless, and switching at a fixed set output voltage of the power supply between the two windings of the transformer. And this is now 14 parts switching between on the delta between the output of the lower voltage transformer winding and the output voltage of the power supply. So real delta V switch, where fixed voltage switch. 14 parts, well, not counting the connectors, and 17 parts. No connectors. They were too cheap for that. And I mean, yeah. Yeah, definitely an improvement. No botches on the backside. Okay. So, it's time to put my little transformer tap switcher on a perf-board and put it into the power supply. I already have prepared a perf-board with all the bigger holes I need and a little bit of isolation routing. We will see why I need that, and I will pick up the parts from my proto board and put it onto the perf board as we go along. So put that out of the way for a second. I've got the missing parts. Okay, focus down here. Yeah, which was a little bit of an odyssey. I ended up, bought that at my local dealer, the 1000 microfarad capacitors, and what else? The 1.5K to watt resistor for alternating, switching the relay coil. I got that from eBay because my local dealer didn't have them available, and to be honest, I didn't want to place a big order at for $50 at DigiKey, because I currently don't have the need. So this is also available. I got my board. I got this is a little bit tiny, so let's make a soft zoom. I got a board layout. Why do I make a board layout when I do perf boards? Because it's helpful, and this time I did a 1-to-1, so I wouldn't miss a pin or two like in my last auxiliary power board. Card link. And so the board outline is a little bit bigger, but that's okay. I hate it when at the edge of the perf board there are these part of the holes left over and it's not clean. Getting to know me. I have this, zooming out again, also in a blown up version, and mirrored from the back, so I shouldn't get lost, and of course I have the circuit diagram. So Yeah, let's get started. Okay, let's start with the resistors. Okay, that's all the small resistors. Okay, our protection diode. And now I made the first mistake. This is all wrong. This is the relay side. Yeah. Let's start a new R2. And just for the fun of it, guess it doesn't hurt to put in the bridge rectifier too. Yeah, everything seems to be in order. And I have now the backside picture here on my side, so I can check if I do something very stupid. Ah, shoot, made a little bridge there. That was all the small fries. Yeah, I solder that in later. What next? Yeah, big resistor. So yeah, by all means, let's put in the power resistor. The pot goes in here. Well, I guess it's time to glue the connectors in, huh? Oh, the bridge rectifier. Still missing its connections. But that's not the main problem. I need a long connection. Here. And now I have silver plated copper wire again on the desk, so chances are high I will be trying to solder with that stuff. Yeah, let's glue the connectors in. This little guy is holding on. Okay, let's let this cure a little bit. The reason why I'm gluing them is, especially the big connectors, go to the transformer and the bridge rectifier. They are normally held in by, yeah, just the solder. But in this case, I had to enlarge the hole to what it is, zero point 0.8 millimeters to 1.5 millimeters. So there is not much of copper left. Yeah, and yeah, would be a shame you rip out the connector and the plug and the connector comes with it. So let's get the relay in. Oh, and I changed the tip of the iron. Kind of got too close. I have a big tip now for the rough work. And the high current connection I will make with 1.5 millimeter solid copper. And that's the reason for the isolation routing, because I was sure I would make a big mess. Yeah, I know I might be overdoing this a little bit, but at 5 amps RMS and a wee bit more peak currents, so at 5 amps 1 milliohm is 5 millivolt drop. And as Woodrow Wilson said in his fourth annual message on December 5th, 1916, and all will agree that there must be no doubt as to the current carrying capabilities of these traces. And yes, I looked that up. Yeah, but okay. Maybe a little bit overbuilt, but better safe than sorry. Yeah, the end is... Sorry. I know where this noise, this scraping noise comes from, and I will try to remove that in the future. Okay. Yeah, let's connect our bridge rectifier to... Last but not least, the trannies. Yeah. That's it. I hope I didn't forget. Is that in focus? Not quite. I hope I didn't forget any traces. I'll find out after. Is that actually soldered here? Maybe needs a touch up. Yeah, but I think it's ready for inspection and testing the connection and everything. And than to go into the power supply. Huh? So I measured all connections on the board. Obviously, I measured really all of them. And seems all to be fine, and now it's time to put it somewhere in here. Down here, I guess. Is that in focus? Yeah. But for that I have to put connectors on these wires and probably shorten them a wee bit. And I need to make a connector to the bridge rectifier, and I have to exchange the bridge rectifier, that's still the broken one, and then I need some connectors to the binding posts, yeah, for the voltage feedback. Yeah, let's do that. Unfortunately, I need a few more holes. Yeah, one screw is going here to that ventilation slot, but the rest will have to be drilled. And I put in here a little bit of perf-board, yeah, right up to the transformer, so everything is in the right angle, as right angly as possible. Sorry, my hand is in the way, but yeah. 3 new holes. Can I zoom in? You probably won't be able to see the markings. Very faint, but I can see them. That's the important thing. Now for marking the holes. Well, that's a wee bit off. That's more off. That's not easy. That's on, spot on. Yeah, that's better. And the last one. Missed it. now the drilling part might be a bit complicated. Well, let's see. Now I removed the heatsink and the bridge rectifier, and now I can almost reach that one hole. Okay. That was a 1mm drill. It was. It's okay, I have enough of them. But I don't... Did that go through at all? I'm not sure. Nope. Okay, one gone. 9 more to go. So yeah, I'm not running out of drills, hopefully. If I can find the hole I started again. Yeah. Better. And this hole should also not be a problem. Sorry. The drill is a wee bit getting into the way. You won't see anything. Okay, that went also through, but I broke the drill again. That's a problem when drilling at an angle. I'm so not looking forward of getting that transformer out, but yeah, that's no way to go. I have to get the transformer out. So that transformer is out again. And yeah, I guess letting the transformer in the start was a shortcut that cost me dearly in the end, and at least 2 1mm drills so far. And you see, when there's enough space and you don't have to put the drill at an angle or bend it, no problem at all. Next stop, 2mm. I'm very careful here at these holes. Okay, 2mm holes. Drills. The holes will be 3mm and 3. Oh, that was just something vibrating. Don't worry. Okay, last but not least, 3mm, and then cleaning up the holes. So, sorry, 3mm. One. 2 and 3. Just cleaning up the holes a little bit from this side. Deburring. And I'll do that from the other side too, and yeah, clean up things, and then we put it all back together. Okay, transformer and everything is back in, and I've put some standoffs on the board, and yeah, it hopefully goes here. Yeah, well, you won't see me can't see anything, so yeah, I'll come back to you when I screwed it. What I want to say, when I fastened it. Okay. So the board is in on some standoffs, obviously. I have a new bridge rectifier in, brand new, so it's hopefully working. Yeah, I had to remove the transformer to do the drilling, and one of the heat sinks, which is okay because yeah, I will use other power transistors anyway. These were intended to work together with a L200, and the L200 thing, yeah, wasn't that successful. Look at the design video or something. And yeah, I finally have a flush screw, so it's no longer interfering here with the heat sinks. So, and that's the microphone cable, or the headset cable. Yeah, it's all very tight around this corner here. I'll have to see what I can do about that. Yeah, next step, wire it up. So I need a connection from the output to the bridge rectifier. And let's start with that. So the connections from the output, that is the already switched transformer windings to the bridge rectifier, are there. And next stop, yeah, the input, that is the non-switched two different windings. Lower voltage, yeah, brown was the lower voltage. Oh, that's important. And higher voltage and neutral to that connector. And yeah, it's tight. It's tight. Okay. Yeah, it's a really tight fit, and yeah, but it works. And yeah, especially here at the back. Yeah, it gets crowded in here, but what can you do? And yeah, I had already, that's yellow and black, sense line to the output left over, and with the right polarity, actually. Yeah. So let's test it, huh? Yeah, I'm always a little bit nervous when it comes to testing, you know, the thrill. So what I basically do is I take the output from the bridge rectifier, which is now hooked up to our transformer tap switch, and I measure it here, and since there is no linear regulator in it yet, I support it, the feedback from another power supply. Yeah, it has been so useful, my revamped one. And yeah, let's power this on. Let's see if something bad happens. No. So we see we got now 20.93. That's effective rectified sine wave. And if I go up here at some point, ah, 35. Let's write down the numbers, or before doing that, put the pot into one of the, yeah, it's already in left hand position. So let's try that again. Okay, so 11.2, 3, 4, 5, 6, 7, 8, 9, 12, 12.1, 12.2, 12.3, 12.4, 12.5, 12.6, 12.7. Okay, 12.7. So so counterclockwise, it's on 12.7. We switched, and if we go down, eleven, 8, 7, 6, 5, 4, 3, 2, 1, 11 volts. Let's turn the pot to the clockwise position. And do this again. I expect this now to switch on a much higher voltage. If I put the pot the right way around. Yeah, clockwise, corresponding to a higher switch voltage. So 14.8, 15, 15.1, 15.2, 3, 4, 5, 6, 7, 8, 9. Come on. Okay. 18.1. And it's switching off again at, yeah, expected somewhere below 17. Okay, oh, at 17. So, yeah, there you have it. Oh, it's so nice to see that. Sorry. Have to play with it a little bit. It's working, and I'm very happy. Yeah, the hysteresis depends a little bit on on the switch point you set, but yeah, that's to be expected if you remember the schematics, where we basically have a voltage adder and a fixed feedback resistor, and that part, the input, we adjust in size. So yeah, so your hysteresis will differ depending on the setting of the pot, but yeah, I aimed for 1 volt, and now the hysteresis is between a little bit over 1 volt and 1.5, 1.7 volts. So that's perfectly acceptable. This is not an exact science. Yeah, we discussed the drawbacks, that the whole thing is a little bit slow on reacting to fast changes on the AC, mains AC side. But yeah, all in all, it's working very nicely. Oh, out of focus. It's working very nicely, and yeah, it's much better than the older one. Anyway, so till next time, which will be next week, but probably not that project. Yeah, I have some other things on my mind right now. So, bye.